Alright, with this podcast we're going to start kind of going into naming, and we're going to begin naming ionic compounds. And what we're going to find is there's about 4 different types of compounds we're going to name, and the first we're going to look at are going to be ionic compounds, and there's really 2 types of ionic compounds. There's ionic compounds where the metal always has the same charge, and another podcast we're going to have metals where the charge can be different. And within ionic compounds, we might have polyatomic ions, we might not have polyatomic ions. And then the other things we're going to name are covalent compounds, or molecular compounds. And lastly, we're going to learn how to name acids and bases. So tonight, we're going to focus on metals with 1 charge. And we're going to refer back to our periodic table, and alkaline metals are always a +1, alkaline earth are always a +2, and then we have this set of 3, silver, zinc, and aluminum, and we go a bing, 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 a 1, 2, 3, silver, zinc, aluminum, yeah! And silver is 1, zinc is 2, and aluminum is 3. And those 3 sets, so alkali, alkaline earth, and bing, 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 are the metals with charges that are always the same. Okay, so we'll just do an example. Let's do Ki. Alright, so as we name these, the metal just has the metal name. Alright, so metal begins, and it stays the same. Metal begins and is the same. Alright, and the non-metal we always mention second. And the non-metal, or the non-metals suffix, changes to "-ide". Alright, so if we have something like this, Ki, if you find potassium, look on the periodic table, it is in the first column, so it's an alkaline metal. So we're just going to write potassium. Alright, and what is potassium with? It is with iodine. Alright, so we're going to write I-O-D. Alright, and ine, if you look at kind of over a lot of those, we have fluorine and iodine and chlorine and bromine. We have oxygen and nitrogen, phosphorus, but all those are going to end with an "-ide" ending. Okay, so iodine becomes iodide whenever it is in a compound. We can do another one, NaCl. This is table salt. Alright, Na is sodium, it's another alkali metal. So we're just going to write sodium. And chlorine, alright, is going to become chloride. Alright, and then we'll do, I don't know, we'll do one more. MgBr2. Alright, so Mg is an alkaline earth metal. It's always a +2 charge, so it is simply magnesium. And bromine becomes bromide. Alright, so that is naming, kind of real quickly. The other thing that I would like to add is, this is going to be always true of binary compounds. And binary compounds, just from binary, mean 2. Alright, so if a compound is made up of 2 elements, alright, and all 3 of these are made up of 2 elements. So one might argue MgBr2 is made up of 3 atoms. It is made up of 3 atoms, but it's 2 elements. So binary compounds always end in "-ide". Right, and we'll kind of refer to that again, kind of as we begin naming other things. Okay, but binary compounds, if there's only 2 elements, it will always end in "-ide". All right, so we're going to go back to black ink. Alright, so the next thing we're going to do is writing formulas. So the top section was really naming. So if we have a formula, how do we name it? And then the opposite thing we can do is, maybe we have a name already on our page, and we need to write the formula for it. So let me come up with a couple names real quick. Strontium. I'll do something kind of funky. This probably doesn't actually exist, but it's nice practice. We'll probably do that one last. And let's do lithium oxide. Alright, the last one we're going to do is calcium sulfide. Alright, so the first thing you might notice about these is just their ending. Notice that each of them ends in "ide," so that means it's a binary compound, so it's just made up of two elements. Alright, and then what we're going to do is, when we write the formulas, we have to make sure that our charges balance, or that they add up to 0. So we're going to start with the last one, because it's going to be the easiest. So if we write calcium, and if we write sulfur, okay, when calcium is in a compound, you should memorize what charge does calcium have. Because it's an alkaline earth metal, it is a +2 charge. Sulfur, when it's in a compound, has the name sulfide. And when it has the name sulfide, it means it has a charge. And sulfur always has a -2 charge. So if we have one calcium, it's a +2, and sulfur is a -2. If we add these charges together, we get 0. Alright, which is what we want. We want a neutral compound. So simply that means we need one calcium and one sulfur. So the way that's written is just CaS. Alright, and that's where you write calcium sulfide. The next one we're going to look at is lithium oxide. So in this case, lithium is a +1 charge because it's an alkaline metal, and oxygen, when it's in a compound, is called oxide, and when it's oxide, it's a -2 charge. So in this case, we have +1 -2, and this adds up to -1, okay, which it can't do that. Alright, so we're going to just put a little cross through that. That's bad. It has to add up to 0. So you might ask yourself, what do I need more of? Do I need more negative stuff, or do I need more positive stuff? Okay, if it's a negative charge, I need some more positive stuff. So what would happen if we had 2 lithiums? Alright, so if we have 2 lithiums, we really have 2 positive charges. So I'm just going to write +1, and we have 1 oxygen still. It's a -2 charge. So what is 1 + 1 - 2? Oh, that's 0. Okay, so really for this to be a neutral compound, I need twice as many lithiums because oxygen already has a -2 charge. So whenever you write this compound, we're really just going to write out Li2O. Our last example is going to be strontium phosphide. Alright, and it's going to look like this. So strontium, it's an alkaline earth metal. It has a +2 charge. Phosphorus, okay, is P. When it's in a compound, it has a -3 charge, and it's called phosphide. Alright, so if we take +2 and +3, we get -1, which again is bad. It needs to add up to 0. So what do we need more of? Well, we need some more positive. So we might change this to a 2. Okay, so if we change that to a 2, over here when we do our little math off to the side, we might go, we really now have +2 +2 -3. Alright, because we have two pluses and a -3. And if we add that up, we get a +1. Darn it. So now what do we need more of? We need more negative stuff. So I'm going to add another phosphorus. Now we're going to do our math again. And we have 2 positives, -3, and we have another -3. So when we add all this up, we get -2. So what do we need more of? We really need more positive. So I'm going to change my 2 to a 3. So I'm just going to cross through that and make it a 3. So I have 3 +2's. So +2, +2, +2, -3, -3. Ah, look at this. We have 0. So whenever we write this compound, we're really going to write strontium 3, phosphide 2. Alright? And that is how strontium phosphide is written. We need 3 strontiums and 2 phosphides so that their charges add up to 0. And that's how you name ionic compounds and how you write their formulas.